everyone. Today in this video, we're going to learn about confusion matrix, where this is one of the important classification evaluation metrics. The other evaluation metrics when we speak about classification are accuracy, precision, FN score, ROC, AUC curve, where all these stands as a derivative of confusion matrix. For us to understand the associated evaluation metrics, first we need to be very thorough about the first evaluation metric, that is confusion matrix. See, confusion matrix is one of the evaluation metric which is going to give us this perspective of how many correct classified records are done from the model, how many misclassified records are there as a result. That is, to what extent model is able to identify the correct records versus the wrong records. That count is going to give us. Let's say if you have 10 records, confusion matrix will tell us among 10 records, how many records model identify it as correct. Like let's say 5 predictions model done it as correct, another 5 is wrong. Something like this. The count is a perspective of confusion matrix for us. Now, how is going to do it? It's going to draw this perspection by considering the 4 instances. That is something called as true positives, true negatives, false positives, and false negatives. So the understanding goes something like this. Confusion matrix will give us a matrix. Let's say the actual predictions will be, if we are talking about a binary data, it will be 0 and 1. So what will be the predicted value? Predicted value will also be somewhere between 0 and 1. If the actual prediction is also 0, if the actual record output is also 0, if the model is also predicting it as 0, we are going to call it as true prediction. So always remember 0 is negative, 1 is positive for us. So what is happening? The actual is 0, predicted also is 0, so it's a true prediction. Since model is predicting 0 and 0 is called as negative, we're going to call it as true negative. Okay, so actual prediction is 0, the model is predicting it as 1. Obviously, it's a false prediction for us. Since model is predicting 1 and 1 is called positive, we are going to call it as false positive. Now 1 and 0, model is predicting, actual is 1, model prediction is 0. So obviously it's a false prediction for us. Since model is predicting 0, 0 is called as negative, this is somewhere called as false negatives. Actual is 0, predicted is 1, it's a true prediction, and the model is predicting 1 and 1 is positive, we are going to call it as true positive. This is a kind of metrics that confusion matrix will give us. Obviously, the diagonal count will give us the total number of correct classifications. That is, true negative plus true positives will give us the correctly identified records. False positives plus false negative count tell us how many misclassification happened with the model. So this is a perspective of confusion matrix as an evaluation metric. Let's just take a small example here and we'll just try to understand that evaluation metric. So you can see the actual label is 1 and the model predicted it also as 1. Then it is a true positive for us. Where and all 1 actual is 1, model predicted also 1. It is true positive. So you can see 1 and 1. It's a true positive for us. 1 and 1. It's a true positive for us. So how many true positives are there? There are 4 instances for us. Like that, we need to understand like false negatives and other 3 parameters here. Actual is 0, predicted it also 0. It's a true prediction. Since it is predicting 0, it is called as true negatives. So where do we have 0 and 0? It is 0, 0, true negative, and 0 and 0, true negative. So true negatives are 3 for us, right? So like that we'll derive other 2. Next we need to understand what is false negative and one more is false positive. What is false negative? It is predicting false and it is predicting 0. So 1, 0, it's a false prediction. Correct. It's a false prediction. Since it is predicting 0, it is called as false negative. That is, you need to understand 1, 0. Where do we have 1, 0? 1, 1, 1, 0. Okay, there is only one false negative. So remaining is what? 0, 1 false positive, 0, 1 false positive. I guess we have covered all of it. Okay, so this is how we are going to arrive to a confusion matrix. So it will be replica of this. It will be true negative, true positive, false positives, and false negatives. If you combine the records here, true negative is 3, false positive is 2. Then false positive. Here it is false negative. False negative is 1, true positive is 4. This is how we can arrive at a confusion matrix. That is, total 7 records are correctly identified by the model. 3 records are misclassified by the model. Okay, this is the perspective that confusion matrix will give us. So with this, we are coming to the end of confusion matrix, an important classification evaluation metric. Thank you all of you.